Welcome to another edition of RCE. I am host Brock Palen, and I have with me my co-host Jeff Squyres from Cisco.
Greetings. How's it going, Brock?
All right. Today we are speaking about the Torque Resource Manager. We have with us Josh Butikofer from Cluster Resources. Josh?
Hi.
And we have Ake Sandgren from HPC2N.
Hi.
So I have to ask before we even start here. This is kind of a traditional thing in the podcast here. I'm absolutely positive that we're pronouncing your name wrong there. Could you tell us how to pronounce your name properly?
Ake Sandgren is the correct one.
All right. Well, we'll try, but we are ugly Americans, so we'll probably get us wrong, and you'll have to forgive us for that.
Yeah.
Okay, guys. So first, can one of you give us a quick rundown on exactly what Torque is for people who have maybe heard of it but not sure exactly what it does?
I guess I can talk about that. Torque, as you said, is a resource manager. So in the HPC industry, resource managers are they're middleware, and they sit above the operating system. They allow jobs to be submitted, usually into some sort of queues or a batch system, and then those jobs are migrated out to compute hosts or compute nodes that are usually also running a daemon that's part of the resource manager. Those jobs are then executed. The daemon monitors the success of the job or its progress, and then when it completes or fails, it reports back to usually a head node, and then you can use commands, or the users can use commands, or the scheduler can interface with the resource manager to find out the success of the job. The resource manager also is, of course, as the name implies, in charge of the resources. It monitors the nodes, their health, their status, resource usage, things like that. So Torque is one of many resource managers, and it is based on the OpenPBS code base, which has been in use for a decade or more now. So.
Okay, I wonder if you could give us so you mentioned OpenPBS there. I wonder if you could give us a little bit of a history, because there is a bit of a tangled history of where all these resource managers come from and who inherited code from what and what ideas, and then there was a bit of a split within this code base itself and whatnot. So could you give us the history of Torque?
Yeah, I'll do my best. I won't go into all the details as I've heard them because it's quite lengthy and probably boring. But Torque, as I mentioned, came from OpenPBS, and OpenPBS was designed and created several years ago by NASA, Ames Laboratory, and a few other organizations like Lawrence Livermore National Laboratory. Veridian Software was also involved. They were a contractor that worked on the OpenPBS source code, helping those organizations create OpenPBS. And Veridian Software was then acquired by Altair. Well, Altair has the commercial rights to distributing OpenPBS, and therefore they have the PBS Pro product that is a commercial closed source version of the PBS or portable batch scheduler. But Torque comes from OpenPBS, and that license on OpenPBS was liberal enough that allowed people to redistribute it, essentially. So Torque came about because over the years, several organizations, lots of organizations, lots of users had created patches against OpenPBS to make it more scalable, to fix problems, to add new features, things like that. And there were so many patches out there that had really built up to, Dave Jackson, who I work with, said it was hundreds of patches. And so there were websites you could go to that would explain how to get OpenPBS up to the latest and greatest, but there were very convoluted directions, like go here and install these 5 patches, then go and install this patch, but don't install this patch next unless you want to work out conflicts. So it was really, really complicated. So Cluster Resources, or probably supercluster.org at the time, started to gather all these patches together and apply them to OpenPBS, and we then started to release this product that we eventually named Torque.
So Torque is actually a free product right now. Like, you can just go to the Cluster Resources website or Supercluster and actually download the Torque and build it and use it without any licensing needs, correct?
That's right. It's open source, and there's really no distribution limitations, so it's totally free as in beer and free as in speech.
Okay, but just to clarify, because I do work for corporate overlords here, there are licensing restrictions. It's just that they're very liberal, right?
That's correct, yeah. There is a license on it, yeah. They are very liberal. Mm-hmm. It's not public domain, in other words.
Okay. And so, just to, what are some of the differences? So if you both came from kind of a common code base, PBS Pro and Torque, what are kind of the differences between them today, other than the fact that, one is, a paid commercial support model and whatnot? But are there significant feature differences between the two?
Between PBS Pro and Torque, you said?
Yes.
Yes, there are. I'm not an expert on PBS Pro, but from what I understand, as time has gone on, there are more and more features that have been put into PBS Pro that are not in Torque, and vice versa. For example, PBS Pro, they have a new way of managing resources called virtual nodes, and it allows you to have more flexibility in controlling some of the resources. They also have other features that allow you to allow you to better define resources that are available, like generic resources. Kind of like, in Maui or Moab, which are schedulers that work with Torque and other resource managers, you have this concept of generic resources, which represent entities that are not processors or memory that you can schedule against, and PBS Pro has support for that. Torque, it has kind of diverged or has features that PBS Pro doesn't have, in the sense that it has high availability features now. It has a lot of features that the community have asked for, for example, having a similar generic resource feature set, or also improving the scalability, changing the way the communication works, things like that.
So, quick question then. So Torque itself does not come with a scheduler, and you always have to hook it up to an external scheduler? Or does it actually come with a scheduler?
No, it actually does come with a scheduler. PBS _ Sched is what we call it. It's a very simple scheduler. By default, it's FIFO. And there are other plugins that come with the Torque source code that you can use to alter the scheduling behavior.
Do many people actually use that scheduler?
No. Okay. I think that some people do, but the vast majority of the people we interact with, and maybe we're biased because Cluster Resources has a scheduler product, most of the people we come in contact with do not use PBS Sched at all.
Okay, so this is actually a great lead-in. Could you give me a crystal clear distinction, because this is something that is frequently lost on most users. What exactly is the distinction between the scheduler and the resource manager? And you mentioned Maui and Moab earlier. I wonder if you could classify that in your definition there.
Yeah, so the resource manager, this is the way I was explaining it to people. The resource manager are the hands and the eyes, and I guess you could say the feet of a cluster for the software layer. So the resource manager, like I said, it watches nodes. It makes sure it understands the availability of nodes, their status, they're up or they're down, their resource usage, things like that. It also will actually start the job and monitor the jobs. It will cancel the jobs. So it handles all of those processes that are started or required by either serial or parallel jobs. So it does all of the lower level work that requires it to interact directly with operating systems and environments to manage jobs and resources. The scheduler, on the other hand, is at a higher level. It communicates only with the resource manager, usually, and it tells the resource manager where to start the jobs and when to start the jobs. And so it'll prioritize workload or jobs that people submit and decide, based on policies that have been configured, who should get what share of a cluster or supercomputer. So going along with the analogy of the resource manager is the feet, the eyes, the hands, the scheduler would then be the brains that orchestrates everything.
Okay, so if Bob and Sally and Sue all submit jobs, the scheduler is the one who actually decides who gets to run right now and where, right?
Exactly.
Okay, and so could you describe then what Maui and Moab are and what the differences are between those?
Yeah, so Maui and Moab are both schedulers and policy engines. So when I say that, I mean they do more than just schedule. They also enforce a whole bunch of different policies to meet